In this lecture, we'll discuss wireless modes of operation. Wi-Fi or IEEE 802.11 defines the following modes of operation for Wi-Fi cards. AP, infrastructure or master mode. The wireless card creates a network with a specified name called SSID and channel and offers network services on it. Wireless cards in master mode can only communicate with cards that are associated with it in managed mode. These are the names, SSID or service set identifiers, of all networks in the range. In the managed aka client mode, wireless cards will join a Wi-Fi network created by an AP and will automatically change their channel to match the channel of that Wi-Fi network. Managed mode cards do not communicate with each other directly and will only communicate with an associated master. Then there's the ad hoc mode. In the ad hoc mode, there is no master, access point, or wireless router. Each wireless card communicates directly with its neighbors. Nodes must be in range of each other to communicate and must agree on a network name and channel. And finally, the monitor mode. Monitor mode, RF mode or radio frequency monitor mode, allows a wireless card to monitor all traffic received on a wireless channel. Monitor mode allows packets to be captured without having to first associate with an access point. Do not confuse it with the promiscuous mode used for sniffing. A wireless card can be put in promiscuous mode after associating with an AP and will sniff the traffic of the Wi-Fi network to which is associated. The monitor mode works by sniffing the packets in the air without associating or linking with any access point. Monitor mode is not used for normal communication, but only for troubleshooting or hacking wireless networks. At this moment, the Wi-Fi card of the Windows machine I'm using to record this video is in managed mode. It's associated and authenticated to an AP, which is also the router of the LAN. This one called CMA. If I start sniffing on this interface, it will capture only data packets destined to it. It won't capture other wireless frames like management or control frames. Only data frames. I'm starting capturing Wi-Fi traffic. Note that there are many types of packets, not only data packets in Wi-Fi networks, such as beacons, association requests and responses, authentication requests and responses, requests to send and clear to send, and many more. Look, we see only data packets. There are no beacons, association or authentication packets captured. In addition, the radio header of the frame is converted to what is called a fake Ethernet header. This is the fake Ethernet header. So in fact, we don't see the full layer 2 header of the Wi-Fi packet because many fields have been removed. This is not the real layer 2 header of the frame. Note that I've used the terms packet and frame interchangeable. Normally, a frame is a layer 2 protocol data unit and the packet is a layer 3 protocol data unit. So when referring to the wireless and Ethernet protocols, which are layer 2 protocols, the correct term is frame, but I think there is no such a big mistake if we call them packets sometimes. Now let's go ahead and put the wireless interface into monitor mode. Remember that you cannot use monitor mode on Windows. I'd recommend you to watch the previous videos where I've explained how to check if the Wi-Fi card supports the monitor mode or not. For this lab, I'm gonna use Kali Linux. There are more ways to enable the monitor mode, and I'll show you two of them. The first one will use RFMON ng, and the second one iwconfig. This is the Wi-Fi interface, which is associated to an AP. The first step is to stop the processes that could cause troubles while working with the interface in monitor mode. I'm running RFMON ng check to list all possible processes like the network manager that could interfere with the Wi-Fi card. If it says RFMON ng command not found, that means that you have not installed rcrack ng, the program which contains RFMON ng. On Kali Linux, it's already installed, but on Ubuntu, Linux Mint, or other Linux distributions, you can install it by executing apt install rcrack-ng. This is how you install it on Ubuntu, for example. And it found two processes that could cause trouble. Now I'll try to kill them. RFMON ng check kill. It's killing the processes. Let's check it again. No process will interfere with my interface, so I'll put it into monitor mode. RFMON ng start and the name of the interface. In this example, the name of the interface is WLAN 0. Check the name of your interface before executing this command. You can run ifconfig before killing these processes. The tool has created a new interface called WLAN0 MON, which is in monitor mode. This is the interface. It's the old name WLAN0 and MON. You can check it also by executing iwconfig. It's like ifconfig, but for Wi-Fi cards. And it's in monitor mode. Now if we start a packet capture tool like Wireshark or TCP dump, we will select that interface to capture packets, and it will capture all packets on the shared medium. So TCP dump -i and the name of the interface, WLAN0 MON. And we see all Wi-Fi traffic in the range. I'm stopping it by pressing Ctrl+C. To return the interface to normal, we need to disable monitor mode as following. RFMON ng stop WLAN0 MON and iwconfig. It's showing that the interface is in managed mode and its name is WLAN0. Let's see the second method used to put the interface in monitor mode. The first step is to disable the Wi-Fi interface. ifconfig WLAN0 down. Then I'll use iwconfig like this, iwconfig WLAN0 mode monitor. And finally, I'm enabling the interface, ifconfig WLAN0 up. Now the interface is running in monitor mode. Let's start capturing packets on the interface, this time with Wireshark. And I'm starting capturing packets on the interface in monitor mode. And we notice how it's capturing all the Wi-Fi traffic. Note that the interface is not authenticated or associated with any AP. It's just capturing all the traffic, including management and control packets, not only data packets, from all clients and wireless routers in its range. Note that the medium, which is the air, is shared, so if a device like a mobile phone is surfing the web at another floor, the packets are reaching this point too and are captured. Of course, they are encrypted, but this is another discussion. I'm stopping the capture. Also notice how it captured beacons and all kinds of Wi-Fi traffic, not only data. And if we are searching for a data packet and take a deeper look, this is a data packet, we also notice the radio header, not the fake Ethernet header like in the example from the beginning of this lecture when I've captured packets with the interface in the managed mode. This is the radio header. And the final note, if you need to restart the network manager, use systemctl start network manager.